Okay, in this tutorial we're having a look at quadratic functions. Okay, so we've got three main forms that we can have our quadratic functions in. That's the general form, where we say it's y equals ax squared plus bx plus c. And this one's good because it gives us the general shape. Okay, so if our coefficient of x squared is a, bigger than 0, so it's positive, it's going to look like this. Okay, if that a value is negative, it's going to invert it, okay, reflect it, look like this. Okay, and it also gives us the y-intercept, which is this c value there. We also have our factorised form, which is y equals a outside of x take x1 times x take x2. So it gives the general shape of our equation again. Based off here, this a value will do the same thing, and also gives our x-intercepts in x1 and x2. Okay, so that's why that one's a good one. Now, turning point form, again, it gives us our general shape based off this a value. Okay, same ideas over here. It also gives us our turning point, which is our at hk, and also our equation for our line of symmetry, which will be at x equals h. Okay. X equals h will be our vertical line of symmetry. Okay, so we're going to start by having a look at factorising. It's just a couple of rules that we can remember to use, which is perfect squares. So if we've got something that's a squared plus or minus 2ab plus b squared, well so if it was plus here, it's going to be a plus b squared. Or if it's take, it's going to be a take b squared. Okay, so that's one that we can utilise. Same with the difference of two squares. If we have x squared take, a squared take b squared, well that's the same as a take b times a plus b. So just a couple of rules to remind you of that hopefully you're familiar with. Okay, but just going to have a look at a couple of things here as well. Okay, so if we've got an equation that's, a quadratic that's x squared plus bx plus c, if we're in this general form, well, to factorise, we look at factors of c that add to b. Okay, so if we have a look at this example here, and we look at 12, we look at factors of 12, which are 1 and 12, 2 and 6, and 3 and 4, and we need a factor pair that's now going to add to 7. So in C, it must be 3 and 4, which means this can be factorised to x plus 3, x plus 4. Okay. Similarly, if we have a look at this one here, we've got x squared take 5x take 14. Okay, our factor pairs of 14 are 1 and 14 and 2 and 7. Okay, since it's negative, we know that one of our factors must be negative. Since this term is negative, we know that our bigger term must be negative. So it must be that we have x plus 2 and x take 7. Okay, if this is in fact plus, then our signs would switch, and our bigger one will be positive and our smaller factor will be negative. Okay? If we have now a coefficient of x squared, so we've got ax squared plus bx plus c, so in our general form, okay, it is a lot more complicated. Okay, we can do a bit of a trial and error approach, okay, which works particularly well if you've just got something like a which only has one factor pair, like it's a prime. Okay, so 2, 3, 5, 7, that sort of thing. You can get around it okay, but a way that will work for all of them, okay, is what we do is we multiply a and c, these values here together. Okay, so 6 12s are 72. Okay, and then what we do is we want to find factors of 72 that are going to add to give our value of b, in this case -1. So we look at our factors as 72, and we really need to think this is -1. So it's going to tell us pretty quickly that we need two factors that are only 1 apart. And in reality, we can see pretty quickly that it's going to be 8 and 9. Since it's -1, we know that 9 has to be the one that's negative. So what we do then is factorise it, ignoring anything else, just using these ones. So we write it as x plus 8 and x take 9. Now we're not finished yet, because if we were to expand that out, we're certainly not going to get back to this, which is what we need. So what we're going to do now, okay, we've done this step of writing a factorised form. Okay, we need to divide x1 and x2, okay, these numbers, by a, in this case 6. So we say we've got x plus 8 on 6, and x take 9 on 6. Simplify those fractions. Okay, it's going to give us 4 on 3, and 3 on 2. Okay. Now what we do is, because that's not very nice, okay, what we do now is we actually multiply this across and make it 3x plus 4 and 2x take 3. Okay, and that's going to be the factorised form of this one here. Okay, so it's a nice little trick to use. Now we'll move on a little bit to solving our quadratic equations, because that's generally speaking the point of actually factorising. So from our factorised form, something like this, okay, and we're wanting it to equal 0, then what we can say is that x will equal x1 or x2. Okay, this is the null factor law, and that's basically saying if you've got a times b equals 0, okay, so two numbers, don't know what they are, multiplied by 0, then we know either a equals 0 or b equals 0, or both. So we use that knowledge. So then we know that this bracket has to equal 0 or this bracket has to equal 0, okay, and that means that x is going to equal this value or that value. Okay, so we should be familiar with the null factor law. Okay, now if we can't, however, factorise it easily, like some of our other methods, if it's a bit awkward to get to this, which will happen, okay, then we can use the general quadratic formula, which again we should have seen before. Okay, and that's saying then that we had this, our general form, okay, here, ax squared plus bx plus c, and then we can use this equation here, which is negative b plus or minus the square root of b squared minus 4ac on 2a. A really, really important equation in maths. Okay, then all we've got to do is sub these coefficients into this equation, and we're going to get two solutions for x, and that's because there's plus or minus part. However, we won't always get two solutions, and the discriminant, okay, which is this part in here, which is delta equals b squared minus 4ac, just the part under here, this will tell us the number and nature of our solutions. Okay, so if the discriminant equals 0, then we know we've got one real solution. So that's going to look like this. Right, we've got one little intersection there, which is at our turning point. If the discriminant is bigger than 0, there are two real solutions. That's going to be a case like this. Okay, and we'll get lots of cases like that. If, however, the discriminant is less than 0, there are no real solutions. That's where it looks like this. Okay, it actually doesn't cross the x-axis at all. That makes sense because if the discriminant is less than 0, that means it's a negative number. And we're in here, okay, and we've got a negative under a square root sign, which we know we can't do. Okay, so what we'll do is we'll use the general quadratic formula to solve this one here. Okay, so what we do is we've got all our different info here. We can simply say, well, a equals 3, b equals negative 2, and c equals negative 6. Okay, now we can simply sub these into our equation. So negative b, that'll be negative 2, which is going to be positive 2, plus or minus the square root of b squared, which is 2 squared, which is 4, minus 4 times 3 times negative 6, over 2 times 3, which is 6. Okay, so we can say, so that's what x is going to equal. So we can then say x equals 2 plus or minus the square root. Okay, we've got 4 times 3 is 12, times 6 we've got there. Okay, it's going to be 72. Okay, plus our 4 can give us 76. Okay, over 6. Okay, which we can then say is 1 plus or minus the square root of 76 on 6. Okay, now we can go through and we can simplify this if we want to. We can turn into, sorry, not on 6, on 3. We can simplify our surd, that sort of thing if we like. It could be a perfect square. Okay, often it won't be. If it's a perfect square, it probably means we could have factorised it easy otherwise. But that means then that we have two answers, which is x equals 1 plus root 76 on 3, or 1 minus root 76 on 3. Okay, so here are our two solutions. Okay, and then we've got one other part that we need to look at, which is about completing the square. So for completing the square, we're starting in our general form, which is y equals ax squared plus bx plus c, okay, and we want to turn it into our turning point form. Okay, because remember our turning point form is really good because it gives us, funnily enough, our turning point. Okay, we use this equation here. Okay, so we've got y equals a outside of x take b on 2a squared take b on 2a squared plus c. Okay, so we're adding in this extra term that we've got to take away here. Okay, is the idea behind it. So we're going to have a look at it for this one here. So we're going to say y equals, okay, so we've got a here, we're going to bring that out. Oh, sorry, I made a little mistake there. Oh, sorry, no I didn't. So we've got 2 outside of x minus 3 on 2 times 2 squared minus 3 on 2 times 2 squared plus 5. Which means we can simplify this bit and so we've got 2 outside of x minus 3 on 4 squared minus 3 on 4 squared, oops, squared plus 5. Okay, 3 on 4 squared is going to be 9 on 16. Okay, plus 5. So y is going to be 2 outside of x minus 3 on 4 squared. Okay, we really think of this as 5 minus 9 on 16, which will give us 4 and 7 on 16. Okay, so therefore we could say our turning point is that we've got to change our sign here. So it's 3 on 4, 4 and 7, like that. Okay, so that's just a little bit of a recap on our knowledge of quadratics from year 11, and hopefully that'll be enough to get you through some of the work that we need to do in year 12.